of diastereomers are stereoisomers that are not mirror images of the same given compound. If there is no word of same given compound, then it is not diastereomer at all. Okay, that's why. See, this example will clearly show the summary of all the things what we were discussing. Okay, this particular example. Look into this. Okay, this is where even this is a slide taken from a very good author. Okay, and you see how people still see our enantiomers and diastereomers. I said, nah, don't directly go for that superimposable mirror image idea and get it wrong. First, you check R and R, okay, and you see if it is R and R, you know that the enantiomer of it should be what? R and R का enantiomer क्या रहना है? It should be opposite. It should be S and S. Yes, that should be the enantiomer. But if you look into the diastereomer, what will happen? So the R and R, one will be R, another will be S. Then it becomes diastereomers. So in this way, if I go down this way also it is SR. If I go this way it is RS. So it is diastereomer. But if I go anywhere in the diagonal path, you see that RR here becomes SS enantiomer. Here RS, this particular carbon of R converts to S, and this S becomes R. This becomes enantiomer. This slide I particularly show for you for all the first year BTech classes. Because I tell you that even now, as a faculty, after so much of experience, if some molecule comes when we prepare in the lab, and if you want to look into diastereomer, enantiomers are identical, I always do this R and S, and then I will confirm it rather than looking the mirror image and superimposing. All that are fine by definition. But to confirm, this is the best way to do, and I want you guys also to follow the best this way and ensure that you don't get it wrong. Any doubt with this slide?
No, sir.
No, sir.
Very good. Now then, I have given you 4 compounds here, A, B, C, D, of 3-chloro-2-butanol. So you take your paper in your hand and tell me which are diastereomers. You can say with respect to A or B, whatever it is. I have given you 4 compounds here, but ensure
So
that
A, C, and B.
no. I want you to first draw R and S and tell me which is diastereomers.
Oh.
Get
Sir,
that
in the
idea.
Fisher projection, we can say by exchange of groups, like single exchange will mean diastereomers.
Whatever you do, I have no problem, but I want to be R and S. That's what I always look forward. Because that gives you easy. What is wrong? Because I have given you a Fisher projection, so it should be directly R and S. You can easily find out. Because you have hydrogens there, which are in horizontal.
So the the upper portion is
Sir, C
S,
and
and
BT
the
will be
lower is R.
No. First, what you do, don't answer. You write it in your paper. First, you write it in your paper in which you have done R and S. You write A and B, what B and C. You write that, and then I will show the answer, and then we will check whether you have written right or wrong. Everyone should do that, please. Sir, assignment karna ka use nahi hai. That's why I teach everything in the class itself. Even the time goes, I don't care. Okay, I want these things should be done very nicely in the class itself. If a
yes,
question
sir.
is, don't answer me. Okay, you just write it R and S, R and S, R and S properly for all A, B, C, D, and then you write below A and B is what, B and C is what, C and D, or A and D. What are the diastereomers here? You have 30 seconds more. Last 5 seconds. Okay, now you can stop. Can we check the answer?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Yes, sir. Is this right? All got this?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, very good. Anyone got wrong? Hey, you can be open. If you got wrong, that's okay. Anyone got wrong? Good, good, really good. If no one got wrong, I think that means it's really
Sir,
good.
I missed B and C for
You
diastereomer.
mix what?
B and C one.
Oh, you forgot, but now you got it, right?
Yes.
Okay, good. So your questions will be like this type, okay? Diastereomers. So we can give four pairs, and we can ask which is enantiomer, which is diastereomer, which is identical. Okay, that will be one part of questions. Okay, then another will be chirality of nitrogen, phosphorus, and sulfur. Okay, so be clear with this. So I hope that there is no doubt with diastereomers or enantiomers now. Okay, fine. So this is another compound which I have already explained, but still I want to place the word. It's called as a meso compounds. Okay, if you have two chiral center, I already told in the class, don't jump seeing that it is an enantiomers or diastereomers or whatever. Ensure that the two things should be ensured. One, the plane of symmetry, another is center of inversion, right? If that two is not there, then only you should jump to the optical activity, right? So the meso compounds are called if there is a plane of symmetry, if you have two chiral centers, okay, and if there is a plane of symmetry, the plane of symmetry can be true atoms and bonds, very important, true atoms, or it can be also true bonds. Then we can call them as a meso compound, which I have already explained to you in the class, okay? But still the name I want to familiarize with you, because we might give you A enantiomer, B diastereomer, C meso compounds, and D identical. So that's why I am putting the word meso compounds here. Meso compounds are nothing but if a compound having like a even number of chiral centers, and then you have a nice plane of symmetry which is cutting to an atom or bond, then we can call that compound as meso compounds. Clear, sir?
Sir, I have a doubt.
Yes, sir.
Sir, if a compound does not have chiral center and has plane of symmetry, then will
Then
it?
we don't talk about there. Okay, it should have chirality.
And sir, if it has chiral center and point of symmetry, means center of symmetry, then will it be called mesos compound or it is just a chiral compound?
It's called a chiral compound. That's why I gave this definition. Meso means it should have plane of symmetry.
Symmetry, it is meso.
Yeah, yeah.
Okay, sir. Thank you.
Okay. Fine, sir.
Sir,
So
only plane of
yeah,
symmetry is
sure.
called meso, not center of symmetry.
Meso only plane of symmetry. Center of symmetry we call achiral molecule.
Okay, sir.
Sir, if there is an odd number of chiral centers, and suppose that odd numbered chiral center lies on the plane of symmetry, then also it is meso compound, right?
Yeah, you can. Yeah, that is a rare case, but still you can call it. If the plane of symmetry is the main number, don't worry about the even or odd, but the plane of symmetry should be the main. Okay.
Sir, meso compound may or may not have stereogenic center.
Stereogenic center, you should be definitely there, right? Stereogenic center, optical activity ranna hai. Then it should cancel each other. For example, you take a compound which is not chiral at all, and then you see a plane of symmetry, then where this meso compound comes. Okay. Fine?
Yes, sir.
Okay. Yes, sir. Okay. Fine. Now this is the important thing which I am going to take in this class. Okay, diastereomer meso compound, I think you have already known, but anyhow, just for familiarization. This is one which is again important compounds with no stereogenic centers. Okay, in that we will be teaching you two different compounds varieties, two varieties of compound. One is allenes, another is biphenyls. So definitely you will have questions from allene as well as biphenyl. So give more attention towards this. Okay, allenes and biphenyls, that's what we are going to talk in non-stereogenic centers. We are taking that examples. Okay, compounds with no stereogenic centers. This guy comes very nicely, allenes. Okay, so first to define, I will take the board. Okay, don't worry about this slide. I will teach you. Hmm? Can we go for allenes now? Okay.
Yes, sir.
Just see whether you can see the board. Hmm? Laser point. What compound?
Sir, in pointer options, you can go to pen.
Pointer option, right?
Yes, sir.
Pointer options. Yeah, thank you, sir. Yes. Now we taken. Okay. Now we'll see. First thing we have to consider is that whether the given compound is an allene, optically active allene or not. Okay, that is the first thing. For example, I have a compound like this. Okay, I have given a compound like this. Okay, and I have given a compound like this. This comes all in the double bond categories. Okay, so this is the first rule we are going to now formulate. We are going to formulate. Okay, what do you think? Which will be chiral here?
So the first one.
Sir, the
first
So
one.
first one.
First one.
First one will be chiral and the
The first
second
one.
will be achiral. Okay, first will be chiral. Okay, that is fine. Very good. Second will be achiral. Now the question, you have to tell me the reason why.
Sir, because in the first one these are on the different planes, and in
Okay.
the second one like perpendicular planes. In the second one, ultimately the HCl and HB are on the same planes, so they
Okay.
won't show chiral. Like there is a plane of symmetry there.
Very good.
Yes, sir.
Okay. Can I
Yes,
use
sir.
this word? Can I say in one case it is staggered, in other case it is linear or planar?
Yes, sir. Yes,
Can
sir.
I
We
use
can.
this word, right?
Yes, sir.
Yes, sir.
Okay, fine. Okay. So in general, we can see that if the double bonds are even number, then you end up with a chiral molecule. If the numbers are odd, okay, I'm talking about the double bond, okay? I'm talking about the double bond. Sorry, yeah. Please, double bond, okay? If the double bonds, this is double bond. Sorry, I want to write big, but pen doesn't allow me. If the double bond is even, then you can directly call them the allene as, this is first condition. Okay, we are formulating the first condition. The double bond is even, then we can think the allene to be a chiral. The double bond becomes an odd, then the molecule itself we cannot call them as an allene. We most of the time call them as a cumines. Okay, cumulines type of compounds. Okay, if it is odd, then it becomes achiral. The reason is that in one case, as you say that the atoms are not in the same plane, I can call them as a staggered to be easily understood. Another case, you can make it planar or linear, whatever it is. Okay, so this is the first condition. Okay, now come to the second. This is first rule. Okay, first rule, whenever you see an allene molecule, what should be your mind should say whether it has a even or odd number. Okay, the second thing we will formulate. Okay, I get an allene now like this. Or I can make a I can make this as a bromine. Hydrogen and chlorine. This is chlorine, okay? So I make another compound like this. Here I have hydrogen, bromine, hydrogen, bromine. Okay. Then I make a yes. So which is among these two? Which is chiral?
Both are chiral.
Second one.
Second one.
Second
one.
one.
Sir, the second one.
Second one.
Yeah, be careful, okay?
So no
Some
one-
said it is for both are chiral, okay? Because this is bromine, okay? If you don't know, it's bromine.
Sir, but
So-
if bromine is on the plane, then
Yeah, I will come to there. Yes.
acha na, sorry. There is
Yeah.
one case. Acha, na.
Yeah, don't worry. If it goes wrong, we will figure it out. That's why we are doing the class here itself, okay? That's why I don't want to teach in PPTs. So if you have these two things, the condition says that you can make a condition that, for example, I make the substituent as A. In this case, I make the substituent as B, and this substituent as C, as this substituent as D. So in alene case, the A, that is, I'm taking the same carbon, okay? The substituent of this same carbon should not be equal. The substituent of the same carbon, that is C and D, should not be equal. If it is not, then only they will show chirality. Otherwise, they won't show chirality. Okay, you see this in this case, this Br and Br are same. Okay, on that idea, I can always say that this is a chiral molecule. In this case, you see this H and Br say different. H and Br is different. So this is A is not equal to B and C is not equal to D. Okay, then this becomes chiral. Even if you look B, please don't see two different carbons. 1, 2, 3. If I number it like this, you have to check the substituents of the C1. Then check the substituents of C3. Okay, don't compare the substituents of C3 and C1 at any case. That is not right. Okay, any doubt with this two rule? See, the first, you might been asked one question, might ask, they will give you 3-4 allenes and they will say which is a chiral allene. Okay, so you have to apply two rules. The first rule says that it should have even double bond, even number of double bond, and the second rule should be the substituent of the same carbon should be different. These are the two rules you have to just apply, and if the two rules gets, you then say the given allene is optically active. Any doubt with these two rules?
Sir,
Yes,
so actually I have doubt in this chiral molecule. So
ahead,
though the A and C are same and B and D are same, how we can say that it is chiral, sir? So means there
This
can
mean-
be
You are
similarity.
you are doing this now. This is what happens if I draw properly this one. Okay, if I draw a plane like this, okay, this will be the different plane of it. Fine. This whole will be the different plane. Might be my drawing is bad here. So the whole plane will be different of this, because here it will be staggered, right? Like Gauge butane, you can think. For example, it will be like if I use a Gauge butane idea here. So you have a Br, H, something like this. It will be different. Okay.
Sir, why you draw same plane for 3 carbon? One plane will be perpendicular to the other
Yeah.
plane.
I cannot show that. That's why it's not a same plane. This is not same plane. It will be how to draw. I'm just thinking. This whole will be like, if you in the class, I have the model. So this will be completely this whole plane. This will be not in the plane like fuming. Okay. this will be the plane and this carbon gets away from the plane. That's why this Br and H will be the different. Okay. What happens? I think you
Okay,
can
sir,
take
got it.
just a minute. I think is this okay to see? You are getting it this way?
Yes, sir. Yes,
Huh?
sir.
Yes, sir.
Yes, sir.
If you are not getting it, please tell me. Okay, don't accept directly. Or next class I can present you with a nice video of Aline also, but it looks like this. Okay, one half of the molecule is in the plane and the other half, you think other half of the substituent is not in the plane. It's more like that. Okay,
Yes.
it will be like a staggered one.
Excuse me, sir.
Yeah.
Sir, when the number of double bonds are odd, so they are in the same plane, so we get a plane of symmetry, so that's why it's achiral, no?
Yeah, that also, and all are, yeah, whatever you can do, you can think in that direction also, nothing wrong with it.
Okay, sir.
So is this two rules are okay for you guys? So only one question I have, which I have to answer, is that of one of my friend, he said that, sir, I cannot visualize this. I will take in the next class nice model and I will show you. Okay? That visualization part I will take care in the tomorrow class. Okay? I will see whether I can get a nice video. Okay? But are you guys are okay with the two rules?
Yes, sir.
Yes.
The
Yes,
first
sir.
rule says that it should have a even number of double bond and the substituent of the same carbon should be different. That's all. Clear. Okay. Now once we know the given compound is optical active, then we have to find out whether it is R or S, right? Okay. Now we will come to that. I will try to use a simple rule. I think this works nicely. That's why I still follow that. This is a bromine. This part works nicely. Okay, you can use this rule. It is easy as well as it works nicely. Okay, okay. So I have an Aline system like this. Now I know that this is double bond, very good, and both the substituents of this are different. So the molecule is chiral. Now I want to see whether it is R and S. What strategy I am going to use is that I told you always I have this idea of looking the molecule in this fashion. Okay, so this will be head. This will be the head for me. I told you in the earlier classes, like this is the way I look molecule, and this will be tail for me. Okay, and in Aline's, so any doubt with this, sir? This seeing through? Use the same principle. Okay, for anywhere you can use the same principle. Even if you go for any stereochemistry, for any molecules, this is the best way to look into the molecule. Okay, wherever the stereochemistry is assigned, the dash and wedge always makes them as the head. Okay, and see from the back side of the molecule. Yes, sir?
No, sir.
Any doubt?
No, sir.
No. Okay. Wherever the dash and wedge are there, that will be the head, and the other side will be the tail. Okay. Now how to number the Aline molecules? Okay. The numbering always starts from the tail. Numbering. So the first thing I can say, wedge and dash side will be the head. That is the first thing. Second thing, numbering will start from tail. From tail. Okay. So can I start the numbering? So numbering, if I start, this is 1, this will be 2, and which will be 3? Methyl, right?
Yes, sir.
Sir, bromine.
Bromine. Come on. Bromine. Yeah. Very good. And then the methyl will be 4. Right? So then I can draw the clockwise. So it looks for me 1, 2, 3, 4. So what direction is this?
R.
R.
Sir, R.
R. Now the condition is that the lowest priority group should be always in the dash. Okay. So the lowest priority group should be in the last. Lowest priority group should be dashed. Should be in the dashed side. Okay, dashed. Not in the wedge part. It should be in the
Excuse me, sir.
dashed. Okay.
Sir, according to CIP rule, bromine will have highest priority. Then we should start from bromine.
No. That's why I tell. Na, you start. That's why. Please don't. This is the easiest way, and this comes right for all the methods. Okay. So you do this
We
way.
should always start from tail.
Yeah.
Whether-
Always start from the tail. Okay.
Okay, sir.
Don't go with that. Then you get lot of confusion. I will show how the confusion comes slowly. Okay. So always start from the tail numbering and then go to the wedge and dash side. Don't start other way around. Tail में से start करना है. That's why I said the first rule is that wedge and dash sides should be the head. Numbering will start from the tail only. And the lowest priority group should be dash form, dash side. Okay. If it is in dashed, then what happens? You maintain the stereochemistry same. If it is in wedge, please change the stereochemistry. Okay. If the lowest is in wedge, change the stereochemistry. Any doubt?
Excuse me, sir.
Yeah.
Sir, if on the head side, if at the bottom it was 3 and above it was 4, then how it would go from 1, 2, 3, 4?
Yeah, I will give you an example. Don't worry. We will do a lot of example. I will not leave you till you understand. Okay?
Sir,
Yeah.
sir, how do we do that numbering?
You will start from the tail first. Okay?
Yes, sir.
Tail में ये दो में कौन सा priority CIP rule में? Chlorine is
CIP
1,
rule.
right?
Okay.
Hydrogen will be 2. Then come to the wedge and dash side. Then among them, which is priority?
Sir,
Got it?
bromine.
Yeah. Then I gave 3 and I gave this 4. Any doubt?
Sir, here shouldn't it become from R to S because H is the lowest one and it's on the opposite side as
No.
dash.
That's why I'm saying, please, H, I have not designated any stereochemistry. Don't confuse. Take rules very simple and this follows very nicely. I have not given any stereochemistry for this guy. So you have to check the stereochemistry of only wedge and dash. Don't go for the tail side. Okay? Just follow the stereochemistry for the given molecule. Bromine and CH3 has been given stereochemistry with wedge and dash that says that one is away from the board, one is towards the board. And H and Cl has not been given any stereochemistry. Okay, that means in the plane. So don't take that into consideration. Clear? Samajh mein aaya?
Sir, so from 3 to 4, we will say that the head side will have R configuration.
No, man, I have written here completely. So what I have written? 1, 2, 3, 4. Now what cycle is this?
Clockwise.
Clockwise is R, right? And
Yes,
the CH3 is the lowest priority group is in dashed or wedge.
Dash.
Then I maintain the stereochemistry. If it is wedge, I will change the stereochemistry. Okay?
Yes, sir.
I will
Hello,
go
sir.
for another molecule. Yeah.
Sir, what if H and Cl was shown in wedge dash and Br and CH3 was shown
That's
through
why
lines?
I will. Don't worry. I will go for the another example. We have a lot of examples. I will show you. Okay? Don't worry. I will go one by one so that it will, so you know you appreciate this rule. Okay? Okay. One we'll go so that we'll appreciate it. keep this as an hydrogen and this CH3. And this will keep it very. This will Cl. Sorry. Okay. Now, can I start the rule? Okay. What is the first rule? How I have to be the molecule?
So head and tail first we have to
Okay.
select.
First rule is head and tail. So this will be my head, right? No doubt
Yes.
with it. And this will be my tail. That is first rule I am done. Now I will be starting my numbering from which direction?
Tail.
The tail.
Tail. Okay. So bromine will be
1.
1, right? Chlorine will be 2.
2.
And methyl will be 3.
3.
And hydrogen will be 4. Now how the cycle goes? 1, 2, 3, 4, right?
Anti-clockwise.
So this is anti-clockwise. What it says? Yes.
Yes.
Now where is the lowest priority group?
Wedged.
Lowest priority group is in wedge, but lowest priority group should be
Dash.
dash. Which means what you have to do? You
R.
will change the stereochemistry. That's all. Doubt?
No, sir, got it.
Okay. Now I will do another example where my friend said it is other way around. You just wait.
I have
will do
one more doubt, sir.
Yeah.
Sir, what is the number of stereo centers in this alene? It is 1 or 2?
You cannot see this is non-stereogenic center saline molecule. That's why I said that.
Sure,
I gave the title.
Sir, configuration is R configuration is of the molecule, right? Means not of a particular.
Yeah. No, not for the particular one. Okay, it is for the molecule. Very good. Very good question. Okay. Now, if I do like this, you have to, because people always have this. CH3. Sorry, sir. This should be single line. Okay. So can I now how I have to go forward?
So it will be
my
like
right
be opposite.
Yeah, my looking will be from this side. Okay, that's why your confusion gets clear by using this law. Not law, sorry, by this procedure. Okay, so this should be my head. There is no doubt. Even the molecule is given inverted. I don't care about it. And this will be my tail. So where the numbering starts now? Numbering
Tail.
starts from this side, right? So this will be 1,
Yes, sir.
2, and then this will be my 3, and this will be my 4. So it will be 1, 2, 3, 4, right? So what direction is this now? This is clockwise or anti-clockwise?
Yes.
Yes.
Anti-clockwise. Yes.
Yeah, and the lowest priority group is in
Dashed.
dash. So I don't want to change the stereo
Yes.
chemistry. Any doubt?
Sir, can you same problem by just exchanging the position of H and D?
Huh?
Exchange the position of hydrogen and deuterium.
Yeah. Yeah, it will be changing, na?
Sir, do it such that the deuterium will be at top and hydrogen will be at bottom.
Yeah. The whole stereochemistry will be changing. That's why we get enantiomers. I will tell you the enantiomers now. Okay. That's why I want to begin with this. Fine.
Sir, but in that case, we cannot decide it is clockwise or anti-clockwise. The numbering will be very upside.
Which one?
No, we have to go from 1, 2, 3. Not we look for 4. We only look for 1, 2, 3. In which direction we are going?
See, you are talking about this one, right?
Yes, sir.
Right?
Yes.
Okay. I will apply the same rule. Don't worry. I won't change anything. So, what is this? This will be 1.
1.
This will be 2. and this will be 3, and this will be 4 for me. So it will be 1, 2, 3. What it is? R. So that's how they become enantiomers.
Yes, sir.
Sir, but if we go 1, 2, 3, 4, then it is some S pattern.
We
Which
don't
1, 2, 3, 4?
we don't
How
consider
you,
the 4.
how you will consider 4, man?
We only look for 1, 2, 3. We go from 1
4
to
you
3
are
via
giving
2.
for the lowest priority to see whether it is wedge or dash,
Got
right? Always
Yes.
go for 1, 2, 3. Okay, because that is we always do in CIP, né? 1, 2, 3, and 4 we consider to keep whether it is wedge or dash. If it is in dash, we say that it is same stereochemistry. If it is wedge, we convert the stereochemistry. Now, if I give molecules like this, and I will ask whether these two molecules are enantiomeric or they are diastereomeric or identical, whatever. So then, can you draw S and R and find it out, right?
Yes, sir.
Yes, sir.
Okay, these are very interesting molecules. For example, no, I'm trying to give you all the way so that you don't get confused, because people tell me after the exam, people came and told me many things. Sir, this rule is good, sir. That's why I'm taking this most of the time, because it fits with anything. You can draw any molecule and you can find it out. So now if it is given like this, how you go ahead? In different
So first we
directions,
select the tail and the head.
yeah, the direction you just look into it.
Up to
So I can turn this molecule direct like this way and do the stereochemistry. I can turn this. If you are not comfortable, I can turn this molecule any direction I want, because I am keeping my wedge and dash at the number. That's the beauty of this. So you won't get confused. You can turn like this. Even if you turn other way around also, what is happening? Nothing will happen. If you are good, you can do in this way itself. So that is also fine. You can turn around, you can do this, you can do this way, or you can do anyway. So the rule comes exactly nicely fits in. Any doubt with this?
No, sir.
No, because if you know this only, I can proceed forward. Because Aleen's message, you will definitely get a question either to find out the stereochemistry, or they might give two Aleens and ask them whether it is enantiomer or diastereomer or whatever it is. And the Aleens will be given in different directions. Okay, you might get it as an horizontal way or vertical way, or the head and tail will change other direction. But you make ensure that your given formula is you are going to use this formula. Wedge and dash side will be always your head. Numbering will start from tail. Lowest priority group should be dash side. Okay, if it is wedge side, change the stereochemistry. This is what you are going to do. And 1, 2, 3 only you see the direction. Don't look for the fourth one. Fourth one is to change the stereochemistry.
Sir, I have a question.
Yes, sir.
Sir, in lab, how do we identify that given is R? Is there any property
Yeah,
that
we have, see, first we have to normally do the optical activity. Okay, we have a instrument called which check the optical activity of the instrument. Okay, so
but
we
sir,
find
R can
just
rotate
a minute.
clockwise or anti-clockwise?
I'm just coming on. Okay, so we do that. First we find out whether the given compound is stereochemically positive or not. Then what we'll do, we will have a literature precedence of the molecule which have the same characteristic feature. That is one way of comparing and saying that this can be R. Okay, looking the literature of the molecules. Other way we have, like, there are diastereomers or chiral compounds where you can attach and find it out. Okay, but it is a very beautiful question what you asked. Sometimes for a new compounds, we struggle a lot to fix the stereochemistry. We
Yes, sir. That's why I
struggle a
am
lot to
asking.
fix the stereochemistry. It's a very good question. In the research level, if you find out a new compound, fixing a stereochemistry of the new compound, for example, many times we isolate the natural products, okay, and morpholine or something time new compounds, then finding the stereochemistry is very, very, very tough. Okay, sometimes we say unassigned, Sometimes what happens, people in 1970s, they found out one stereochemistry which has been rectified later on. People said, yes, it was, but after 20 years of research, breaking down the molecules, doing chiral symmetry, asymmetric synthesis, all these things, finally people found that the stereochemistry is different. So this all happens, okay? Don't worry. But it is tough. It is not that easy. Good questions. You guys are really good, man. So any doubt with Alins? Sir?
Sir, I have a question,
Yes.
like not related to this topic. Sir. Somebody from our section, Salman Khan, is not able to find the team in his like in the Teams app. So he might
What?
have been removed or something. So he wants himself to be added.
Salman, how it is possible?
Like every day he has to be given a separate link. Like he cannot find the channel.
Oh, fine. Can you ask Salman Khan to send me a mail so that I can add his name and everything? Huh?
Sir, he has requested to join the meet. I think you can add him directly from the Microsoft Teams itself.
Where is requested? I don't have him. Salman Khan. How to find him? Yeah,
So he's already in team. His name is in team member. I just.
Yeah, then how is not allowed to get in? Salman Khan, you are there in the meet? Yeah, if he is not there, ask him to mail me one time. That's enough. Huh? With his email ID. Okay, I will again include him. Okay? Is it just fine? You guys are not saying anything. Yeah, okay. Okay. So, any doubt with the Salins?
No, sir.
Sir, it will be there. So ensure that I tried all the methods, different style of checking the allene molecule. For me, this was the best way to find it out. Okay, it worked really nice, and it works exactly. So just use the same formula what I have mentioned in the class. Remember that things. Okay. So in this class, what I have teased you, diastereomers. We have looked into the meso compounds, and we have started looking into compounds with no stereogenic centers, the whole molecule. I had a nice question, sir. It is related to carbon. No, it is related to the molecule. So we are talking about RNS related to the molecule. Very nice question that was. Another thing, how we can assign RNS. It's so interesting to listen all these nice questions from you guys. So can I repeat the rule once again, or you are happy with the rule for allenes?
Yes, sir, it's okay.
Any doubt with the rules? So basically what happens, you have a wedge and dash side, and you have two bold lines. So always you have your head to tail. Head should be always on your wedge and dash. That is first thing. Second thing, you ensure that your numbering starts from the tail. And third thing is that you keep your fourth group, that is the priority group fourth, should be in the, if it is in the dash, keep the stereochemistry same. If it is in wedge, make the stereochemistry different. And before that, you figure out whether the given allene is optically active. If it is so what are the two conditions which makes allene to be optically active? It should have an even number of double bond, and more importantly, the substituent of the same carbon should be different. So that's, I'm summarizing that. Any doubts? So I hope that if I ask allenes, you all will be happy to answer questions, right? What I will do tomorrow class, I will take some problems of allenes, some critical problems. See whether you guys can answer it. Kya bol rahe?
Yes, sir. Sure.
Yes, sir. Yes.
Do it in the class itself, right? That will be more fun.
Yes, sir.
So tomorrow I will be teaching you biphenyls. Okay, that will be the main important biphenyls, and we'll do some problems on this allenes and biphenyls, and then we are done with the stereochemistry. Okay, then we have to go for the conformation analysis. And tomorrow, once the 1 hour is over, I will upload all my videos related to, not videos, the PPT related to stereochemistry, and I will ask research scholars to upload the questions related to stereochemistry. So any more doubts, you can ask me now.
Sir, I have a doubt.
We have 2-3 more minutes more.
Sir, in case of finding enantiomers for allenes, we just find out the RS configuration. So if RNS is present, then they are enantiomer, and if not, they are identical.
Yes, yes.
Okay.
Go
So
with that.
is there any case of diastereomers in allenes? Means I don't think so, but still.
You won't get it. You won't get it at all. Okay. Either people will say enantiomer. Okay then. Any more doubts?
Sir, in the slide, it's written that allenes have no stereogenic centers, right? But actually, allenes, this allene should actually have 2 stereogenic centers, right?
No, stereogenic carbons. There's no stereogenic carbon there because there are not chiral. No different, 4 different substituents of the carbon.
Sir, in the internet, the definition of stereogenic center was if you exchange the 2 groups attached to it, then you'll get another stereoisomer. That is applicable in this case, right? So they should be stereogenic center now.
Yeah, see, we had this definition which keeps on updating all these things. Okay.
Okay.
So I think right now we'll keep like this. Okay.
Okay, sir. Got it.
Yeah. Is sir audible? Anubhav Mandel. You're audible only. Who is? Okay, fine. So today class you learned something good?
Yes, sir. Thank you, sir.
Okay,
Yes, sir.
Okay, guys. Then
Thank
thanks
you,
a
sir.
lot. Have a nice lunch.
Yes, sir.
Okay. Get back to your class by 3.
Thank you,
Okay?
sir.
Okay, then.
Thank
See
you,
you. See you tomorrow by
Okay,
10.
thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Sir, whatever.
Excuse me, sir.
Our attendance. Sir, our attendance. Sir?
I'm not hearing you, Anil Jyoti. Can be louder. Do anyone hear what Anil Jyoti is saying?
So yeah, he's asking about the attendance.
Attendance, I have all the downloaded. Every class, once it is over, attendance gets downloaded.
Okay, sir. Okay, sir.
Okay? Yeah. I keep that option in team. Once the class is over, attendance gets downloaded. So I will check that.
Excuse me, sir.
Yeah.
Sir, let's say we have a 5-carbon allene with double bonds, like 4 double bonds in there. So in that case, we can get like diastereomers in that case, like if we find out the R and S configuration at each of the planes.
Yeah, you get enantiomers, but the diastereomers, 5 carbon. 5 carbon will be odd number, no? You are talking.
Yes, sir. I mean, there will be four double bonds, so there will be out of plane. There can be 2 R and S, like that type of. I mean, 2 stereogenic.
The whole molecule will be whole molecule will be enantiomer. I don't see any diastereomer there, even if it is a whole molecule. I don't see that. I cannot think about it right now.
Sir, like first there will be two RNS, like possibilities of 2 RNS, right? Like in the 2 pairs.
Yeah, you guys are there, but I am just thinking about it. C11, 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 where it will change this R and S. I don't see.
So can you just show an example of 5 carbon allene configuration, like?
Yeah, it will be more like a 2 carbon only. So if I see the gauge butane, it will be more same like that only. I have to keep the first one and the last one. Middle I don't consider at all.
Sir, but the first and the last one will be in the same plane, and the middle one will be out of plane with
say
first
that
and last.
C11C, C11C, and in the C3 there will be change, right?
Yes, sir. Yes, sir.
Yes, sir.
Yeah, that can be also possible. But right now I cannot say yes or no. Okay, I have to check it. Next class I can say authentically. Okay.
Okay, sir.
I will have a look in the next class. I will check that and I will say you. Okay.
Okay, sir. Thank you.
Okay. Thank you, guys. Okay. See you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yeah.